Welcome to the third part of our short introduction to Python, which is about loops. Loops are very important in programming because if you need to do a task again and again and again, then in real life you would need to do it again and again and again. But in programming, you just tell the computer, do it 10 times, do it 100 times, do it until the temperature drops to so and so many degrees and then stop, or similar. So I will just cover the most basic type of loop, which is a for loop, and this is also the loop that we use most often. We define a for loop here in our very first example, and I say for I in range 10. What does this do? For I in range 10. So I have a variable called I, and range 10 is it's a range. It's similar to a list. 10 elements from 0 to 9. So I iterate through those 10 elements, and in the first iteration I will have value 0, and the second iteration it will have value 1, and so on. So it iterates through this range until a last time when I has value 9, and then it won't have value 10 because it does it 10 times from 0 to 9. And we're actually not interested in this short example in the value of I at all, just that we iterate 10 times through the code that is indented below the for loop. So it could be more than one line if I add another line that's also indented. And in each iteration, I put one brick next to the other. So when I execute that code, I would expect that it prints put one brick next to the other 10 times. So if I was more creative, I could have printed some pattern or so that changes with each iteration, but that's just a very short demonstration. I want to execute something 10 times, and I do that by saying for I in range 10. A bit more interesting is actually using the value of I, and that's done in the second example. I could, for example, iterate for I in range 70 to 100 in a step size of 5. So this will now iterate, and I in the first iteration will have a value of 70, and I will print that. Then in the second iteration, I will have a value of 75, and I will then print the value of I, which is then 75. And then again, with 80, with 85, and I always print I, with 90 and with 95, and then I stop because 100 is not included. It is the upper limit that is not part of that. It's the definition in range. So the upper limit is not included. It starts at the lower limit. And we do that. And that's what it does. So I start with 70 and I print it. So in the first iteration, I is 70. In the first iteration, I is 75. Then it's 80 and so on until the last time, 95. Then it would have 100, but the for loop says at 100, I stop and don't execute this for loop anymore. So in general, you need to be a bit careful with those loops. If you accidentally had 1000 instead of 100 here, then you would execute it many times. It's also possible to get into a loop that never finishes because this statement here is always true. You need to be a bit careful with that so that your loop actually finishes. And when you do heavy computations that need some computation time, for example, if each of these would need 1 second, then I go through it 6 times. It's then 6 seconds. Of course, just printing a variable is very short, but in deep learning, one more iteration could actually be quite computationally expensive. So this about iterating through numbers, defining a number and iterating through it. You can iterate through any array or list in Python. So in the next example, let's define an array called words, and we want to iterate through each element of this list. And I define another variable called sentence length. What I then do is for this word in words, do those two commands. So for this word in words, this means for something in words, so I iterate through each element of words. And in the first run of the for loop, the variable called this word will have value we. In the second run, it will have value love. In the third run, it will have value pulse, then and then Bloomsbury, and then it ends because it reaches the end of my array or list words. And what do I do in each iteration? First of all, I print this word, which is the present element that we have in that particular iteration. And then I do something with sentence length. I increase sentence length with the length of this word. So in the first iteration, sentence length was 0. Then I add the length of v. So then sentence length should be 2. In the second iteration, I add 4 to it. So then sentence length should be 6, and so on. I add the length of each of these strings in each iteration. And at the end of this, it ends when the code is not indented anymore. I define another variable, average word length, and the average word length is the sentence length that I've just calculated divided by the number of words in that array. So that's the length of this array. The length of an array is the number of items. And then I print the average word length, and I've already done that, which is bad, so you already spoil it, but I will run it again to show that this is actually executed. So I iterate through array words, and I say for this word in words, I print this word. So first I print we, and I do that computation. Then I print the second element love. Then I print the third element pulse, and I always do that computation, but there is no output. And in the very end, I calculate the average word length, and I print the average word length on the screen. So this is 5.4. So these are the very basics about loops. Loops are enormously important in programming. Loops are something that's done iteratively. So it's usually done in series, because in our short example, sentence length is always dependent on what sentence length was before. So there is not much room for parallel programming. So if I iterate through that 100 million times, through 100 million elements, and that's quite common in machine learning, then I do that quite often. And in this example that I've written here below, 100 million elements, and one iteration takes just 5 microseconds, which are a few operations on a gigahertz processor, and it can take several minutes. So don't worry about the time that it takes to compute a loop. Loops are very important, but keep in mind loops are executed in series. And if you have many elements, then computation time can be long or too long. So thank you very much for watching this third of 6 videos about our short introduction to Python.